Hello everyone. In this video, we are going to discuss the a topic that is asked in different exams in like IIT JAM, CVT, PG, right? PG, and some BSc math exams also, right? So the topic name is convergence of sequence. What is this? This is convergence of sequence. So I hope you are already uh, aware with this topic, and this is very easy topic. So there is one definition of convergence in the book in the syllabus. It is formal definition. Formal definition what says? It says a sequence, a sequence. Suppose I'm taking a sequence. The sequence is xn. Suppose this is a sequence xn. Sequence xn is convergent. I will explain it in details. A sequence is convergent to L. Suppose any limit the sequence converges if there exists a natural number, there exists a natural number, and this is a natural number, right? This is in set of natural number in such that what is the condition? It says this modulus of xn minus L is less than epsilon for any epsilon positive. What it means? This is the definition of convergence of sequence, right? How we can understand with easily because it's looking very like how what we are getting the idea of convergence. The convergence is what? Firstly, we will understand the idea intuitively, then we will uh, break through this whole definition with small and easy pieces. Okay, so the convergence is what? Convergence is what? So if you talk about the convergence or converge, so there is a sequence. A sequence has infinitely many terms. So there is a sequence xn. It has terms like x1, x2, x3, and x4, and so on. And when you are moving the more terms, x100, x101, and so on, x1 lakh, and so on, then your sequence is going towards a number that is L. So we are saying this xn is going to be converge L when n goes towards the infinity. Means you are going after more terms. Your xn is going to be converge to L. So this is the intuitive idea. Now comes to the definition. This definition, right? What it is saying? A sequence xn is converges to L if there exists a natural number. So for understanding this, I am taking an example here. Very simple example. Suppose my xn is equal to 1 by n. And we already know my limit L is equal to 0. So what it is happening, we will understand by the definition and intuitive also. So uh, let's go to, firstly we are going to understand by graph or by just taking points. So suppose this is my xy plane, this is x and this is y, right? So I'm taking the all these sequence here. So what is my x1? I'm writing here x1 is 1 by 1 means 1. So where is x is equal to 1? Suppose this is my x is equal to 1. So this is 1 means what? This is my x1 first term. What is the second term? 1 by 2. There is here x2. What is the third term? This is 1 by 3. This is here. This is 1 by 3. Right? When you are moving x4, x5, x6, x 100, 1000, right? Okay. Oh, sorry for this system. Is there is some, I think, technical issue. Okay. Uh, I had given some sequences here, right? What I was saying, this suppose x thousandth term is 1 upon this. So here is a number. This was 1 by 2, this is 1 by 3, and if you are drawing this terms, this is very near to 0. This is very near to 0, like this is your xn, x 10,000, right? So when you are going to infinity, xn, where it is going towards 0, you can see this is going towards the 0. So after some stage, after getting n, so my definition says if your sequence is convergence, then there exists a natural number n such that modulus of xn minus l less than epsilon. Now come to the condition, come to the definition condition. So we know my sequences converges to L. So what condition should be fulfilled? Xn minus L is less than epsilon. I'm taking any positive epsilon I'm taking. I'm saying my xn minus L is less than epsilon. Means the gap between the sequence xn minus L is less than epsilon. Epsilon any positive number, very small positive number. So my xn is 1 by n, L is 0. This is less than epsilon. Now, can you calculate the value of n here? This is 1 by n less than epsilon. So this is nothing but n is greater than 1 by epsilon. This is the condition for n. Now focus it. This is n says this should be 1 by greater than 1 by epsilon. Now epsilon here, we know epsilon is very small. So this is your actually n that I was talking about, right? So uh, this is my n. Now the condition says after taking this n, any number n, if you choose any number after this n, you will get the condition should be whole. Means by taking any epsilon, you always will get a natural number n, so that this gap xn minus L should be less than epsilon. Okay. So, if I take the proper logical value of epsilon, suppose I am taking very small number 0.00005. It's very small and very near to 0. I'm zooming it. This is my 1, this is my 0, and I'm taking epsilon here. Suppose this is my epsilon, right? So what is my n for this sequence? N should greater than 1 by epsilon. Put the value of epsilon 0.00005. Now what is the number? So this is 1, 2, 3, 4, 5 divided by 5. So this is 20000. Okay. So this n should greater than 20,000. You will get for any number, any fixing epsilon, you are getting the n. Now, if you take any n greater than n, if you take any n, suppose you are taking n greater than n, suppose you are taking n is equal to this. Suppose you are taking this, right? Now, you can check your xn means x 200. Always this whole xn minus 0 is less than epsilon. Okay, so why? Because I hope you got the intuitive idea why this definition are working here for sequencing. So logically what we are doing we have a sequence term x1 x2, and we are going towards xn, and we are fixing any epsilon here, any epsilon. And when we are fixing any epsilon, we are trying to get a natural number n, so that after this n, if you take any value after this n greater than n, the condition of xn minus L is always less than epsilon. Means by choosing any epsilon, you always get a stage, always get a natural number n, so that by taking any number greater than this n, you always will get the this condition hold. Means your xn is very near to L. Your 1 by n sequence is very near to L, means my 1 by n sequence is going to be 0 as we are approaching as n tends to infinity. So this is the idea. Okay, so hope this concept is clear to you. If you talk about the more examples, so let's talk one more example also. Suppose I'm taking another example like 1 by n sequence. This is my sequence. So what is the term of these sequences? The first term is x1. This is minus of 1, minus 1. x2 is, can I take minus 1 to the power n? This should be more general, right? Minus 1 to the power 1. So this is minus 1. Minus 1 by 2 to the power 2. So this is 1 by 4. x3 minus 1 by 3 to the power 3. So this is minus 1 by 27. Now what is happening? Let's see the graph. So this is my 0. This is my 1. This is my minus 1. These are the terms. So first term is 1. First term is x1. Second term is 1 by 4. So there should be like here. This is x2. I think this is x3. And when you are moving the more terms towards the more terms, x100, x1000, x1 lakh, then your sequence is going towards the 0. So you can say that minus 1 by n to the power n goes to 0 as n tends to infinity. Okay, or by definition, you can say by epsilon delta definition, how you will see xn minus L is less than epsilon. Now your motivation is to find the n. What is n? So here minus 1 to the power n minus 0. This is less than epsilon. From here, you need to find the value of n in terms of epsilon. So can I can write minus 1 by n to the power n is less than epsilon. And here, this is minus 1 to the power n and 1 by n. This is also modulus less than epsilon. Now, what I can write? This is 1 now because minus 1 to the power n, the modulus is outside. This is 1 times 1 by n because n is also positive here, epsilon, right? Okay, there is also the power of 1 by n. Okay, power of n. So here, this is n to the power n is less than epsilon. So what is the value of n? N to the power greater than 1 by epsilon. So what can you say about the value of n here, right? So there is some method also to find the value of n in this situation also. So you will get any n is greater than some function of epsilon, and that should be your n. And after taking this n, you will get the this is not natural number, this is stage n, any natural number. This is a natural number you will get by solving this. Okay, so I hope you got the idea by taking two examples how this definition works for convergence of sequence. And there is lot of things to discuss about this topic, about this convergence. It's a very rich and very rich concept in mathematics. Hope the video is clear to you. If you have any doubt, you can ask. Thank you for watching.